Good morning, dear students. Let's move on towards the next problem of your torsion. This will be the last problem of your torsion, and hence your this module will get completed. Okay. So if you have any doubts, you can contact me directly so that I can help you out, and you can solve more problems on this using the textbook SS Bhavekatti. Okay. A shaft is required to transmit 245 kilowatt power at 240 rpm. The maximum torque may be 1.5 times of the mean torque. So this one statement is a little different compared to the other problems whatever we solved. The shear stress in the shaft should not exceed 40 Newton per mm square and twist 1 degree per meter length. So these are the conditions given to you. Determine the dia of shaft. Take G equals 80 kilonewton per mm square. You see, determine the dia of shaft. They have given two conditions. If shaft is solid, when the shaft is solid, only one diameter will come into picture, that's D. That D you have to find out. And if the shaft is hollow with external dia twice the internal dia. A very interesting problem. We'll try to solve this. Okay. And the statement here different kind is the maximum torque may be 1.5 times of the mean torque. So let's see what the statement we can use this in the problem. Okay. So without wasting time, let's move on towards the solution. So I think today's date is 19 10 20. So given, what are the things given to you? You just write down. Okay. So power P is given 245 kilonewton. That's nothing but in terms of, sorry, kilowatt. Okay, kilowatt. Now in terms of Newton, 245 into 10 to the power of 6 Newton mm per second. N equals 240 rpm. T equals 1.5 times of mean torque. So that statement you can use it in this manner. Q equals 40 Newton per mm square. Theta should not exceed 1 degree. That's in terms of radians we need to convert. It comes 0.01745 radians. Length L equals, or capital L, 1 meter. That's nothing but 1000 mm. G equals 80 into 10 to the power of 3 Newton per mm square. Okay. So now first of all we'll go for the calculation of T. Calculation of torque. So the same step, power P is equal to 2 pi nt by 60. So power we know 245 into 10 to the power of 6, 2 constant, pi constant, n they have given as 240 rpm, T we need to find 60. So from this we get T is equal to 9.748 into 10 to the power of 6 Newton mm. Sorry, I think it was little blur, so now it's visible clearly. So this was the calculation whatever I had done. So now it is said torque T is equal to, this we can take it as T mean. Okay, 1 point times of T mean, or mean torque. So that is 1.5 times of 9.748 into 10 to the power of 6 will give me 14.62 into 10 to the power of 6 Newton mm. So this is the only twist. So this is the only twist here what we can what they have asked in the question. So now once getting this, so they have said to find out the dia. So calculation of diameter. Now calculation of diameter is in two forms. So one is when it is solid, when it is hollow. Okay, so let's go for first case in calculation of dia, when it is solid shaft. So we know T by J equals G theta by L. Relate this because G theta by L is also given, Q is also given. So once we relate with this, then T by J equals Q by R. Okay. So now 14.62 into 10 to the power of 6, J is pi d raised to 4 by 32 equals 80 into 10 to the power of 3. So because it's kilonewton, in terms of Newton I have converted it already in the given data. 1.754, that's nothing but your theta value divided by L. L is 1000. So from this you can calculate this. So I'll directly give you the answer of D. I get D raised to 4 equals 1.829 into 10 to the power of 6. Okay, you please calculate it or else it will be a waste of time. So now finally D, I get it as 1.829 into 10 to the power of 6 raised to half. So D equals 101.62 mm. Okay, so this is one time D of solid we have found out. Then we know that because they are given Q also, so highest of the D I need to select it as a solid diameter. So we know that T by J equals Q by R2. Okay, Q by R also we know. So substituting the values, 14.2 into 10 to the power of 6 divided by pi d raised to 4 by 32 equals Q is 40, R is D by 2 again. So after solving this, on the right hand side part, I get it 148.91 into 10 to the power of 6 divided by d raised to 4 equals 80 divided by D. So D taking on one side, bringing the remaining terms on the other side will give me like this D cube. So because I've taken it, so D gets cancelled. So D equals 1.861 into 10 to the power of 6 raised to 3 by 1 by 3. So finally D I get it as 123.03 mm. Okay, so therefore I can say dia of solid shaft equals the maximum one, 123.03 mm. Now for when shaft is hollow. So this is for the solid shaft. You have found out the dia. So when shaft is hollow, they have said D external is equal to 2 times of D internal, or it can be Di equals 0.5 times of D external or outer. So T by J, here also will apply the both cases. T by J equals Q by R, 14.62 into 10 to the power of 6 divided by pi d naught raised to 4 di raised to 4 divided by 32, that equals 40 by d outer by 2. So we know di equals 0.5 times of d naught. So 1.62 into 10 to the power of 6 into 32 divided by pi into d naught raised to 4 minus 0.5 d naught the whole raised to 4 equals 80 by d naught. So next I'll write the same date, 19 10 20. So therefore I get d naught after calculation 125.6 mm, and similarly di I get it as 0.5 times of 125 times 6, so that is 62.8 mm. Okay. Similarly, we know that you have to find by both the cases t by j equals g theta by L. So 14.62 into 10 to the power of 6 divided by pi d naught raised to 4 minus di raised to 4 divided by 32 equals 80 into 10 to the power of 3 into 0.01745 divided by, so after solving this, 14.62 into 10 to the power of 6, 32 comes up, pi in the bracket d naught raised to 4 minus 0.5 d naught the whole raised to 4, it gives on other side 1.396 answer directly because no unknown terms are there. So finally 467.84 into 10 to the power of 6 divided by pi d naught raised to 4 minus 0.0625 d naught raised to 4 will go 1.396. So finally I get d naught raised to 4 equals 113.78 into 10 to the power of 6. So d naught equals 113.78 into 10 to the power of 6 raised to 1 by 4. So d naught equals 103.28 mm. So therefore di equals 0.5 times of 103.28, that is equal to 51.64 mm. So comparing these two values and these two values, this one is the highest. So therefore provide hollow shaft of inner dia 62.8 mm and outer dia 125.6 mm. So here completes your problem as well as the module. Okay, thank you.